Hello everybody. Here's your warm-up. You don't need to copy down the sentence. Just copy down y equals x plus 4 times the quantity of 3x minus 1. And then I want you to plug in -2. You can press pause while you go ahead and work through this. Obviously they said there's a mistake in here and they want you to solve it for y correctly. So it's not supposed to be y equals -14. It's supposed to be something else. So go ahead and do that and see what you get. Press pause and then check for the solution. So hopefully you found that y was supposed to be equal to -30, and the mistake was in the third step, -2 and 4 were added together. So basically they didn't multiply that 4 and the -7, they just added those together first. So that was the mistake. Okay, I'm going to go back and give you another one. I want you to do the same thing. So you're supposed to write down y equals negative with x squared minus 4, and they want you to plug in -1. A mistake was made. So take a look at this and see if you can figure out what the mistake was and then solve for it correctly. Go ahead and press pause and work through this for a minute or so. It's not supposed to be -3. And I'll give you a hint. This is a power right here, and a negative in front of it means multiplication. So that's a hint. Let's see if you understand what to do. Did anybody actually get -5? Y is equal to -5. That's what it was supposed to be. In the third step, the negative sign was distributed to the -1/2. So essentially what happens is this square becomes -1 squared becomes +1, but that makes it a -1, so it should actually be -1 minus 4. Let me say that again. You would square the -1 first. -1 times -1 is +1, but that right there is like saying the opposite of -1 squared. So this actually should be a -1 right here. So go ahead then and turn to your binders to the activity for the day, which is 4.3a. Okay, this is what 4.3a should look like. You're talking about features of graphs. So the cool part is there's very little calculation to do in this. It's really very much an observation lesson. You're really just kind of describing what's going on. So the I'd like to actually do these definitions before we do any sorting, because these definitions will actually help you. And it says, define increasing, decreasing, constant, and inflection point in your own words. Well, I'm going to help you. I'm going to use words that will help you to then go back and do the sorting. So when something is increasing, you know it means it's like going upward. So think about it this way. It's when the y values, well, increasing means doing what? Are increasing as the x values are increasing. And that makes sense, hopefully. Now this is obviously as we move from left to right on a graph. So think of it like this. If this is a coordinate plane, and you had an increasing graph, it would look like that. It would be going uphill from left to right. And I just drew a line, which means you probably recognize that as a positively sloped line. But it could be a curve too. So anything that's going up on the y, as the y values increase as the x values increase. Well, obviously decreasing is the opposite of that. The values of y are going to do what? The y values will decrease, of course. Decreasing as the x values. Now don't say decrease though. Think about this. As you go from left to right, aren't the x values getting bigger? So the y values are decreasing as the x values are increasing. Okay, and again, if I drew a little coordinate plane and I kind of went like that, as we go from left to right, the y values are getting smaller and smaller. Okay. Now what about a constant? Now we're talking about a graph, a constant graph. Well, you should already think of this as a zero slope, right? So this is where the y values are not increasing or decreasing, they're staying the same. The y values stay the same. And if the y values stay the same, you think of that as a flat graph, like a horizontal line, right? So y values stay the same as a constant. Okay, now this is something that you haven't been exposed to, is an inflection point. Now guys, inflection points are basically any point on the graph, if it's a curve or something like that, or it changes direction, it's a point on a graph where it changes directions. Okay? So if it's going uphill and then went downhill, that would be an inflection point. And if it was going downhill and went uphill, that would be an inflection point. The minute it starts going from uphill to downhill or downhill to uphill, those are inflection points on the graph. So make sure you have these definitions before you go on to the actual sorting and talk about them. Okay, now that you have the definitions, you have graphs on page 68, 69, and 70. They look like this. It says sorting graphs for activity 3.3. They're on the following pages. So what you're supposed to do is you're going to write the letter of the graph that for the correct description of what's happening. So, for example, it says the function is increasing on the entire graph. And you know what increasing means. It's going up from left to right on the entire graph. So I'll go through this one problem for you here. So let's look through our graphs. So does graph A look like it is increasing along its entire graph? Does that look like it's going uphill? Well, hopefully you recognize that it is. How about B? It's increasing here, but then it flattens out, so that one's not. So A is definitely one, B is not. How about C? Is this increasing along its entire graph? Well, it's increasing here, and increasing here, but what happens here? Right as it's around the origin, doesn't this flatten out a little bit right here? So it's no longer increasing here, it's flat here, so C is not one of them. D obviously is not increasing, it's going down then up. How about E? E, let's see. All these dots are going uphill, absolutely. So E is one of them, and this is how you're going to continue this activity. You're going to label all the letters. Then let's look at F. What do you see on F? I don't see a whole lot. Oh, I see just a horizontal line here, perhaps? Not increasing, certainly. How about G? Take a look at G. Nope. Down and up. H. Up and down. I. Down and then flat. J. Up, down, up. No. K. It's going up a little bit. Then it's really steep and then up and then, wow, actually K is increasing. The Y values are always increasing as we're going from left to right. So K is another one. L. Nah, up and down and up and down. Nope. How about M? Let's see. It's starting here and then everything's getting slightly higher. Yeah, and then it continues up. So I would definitely say M is increasing over its entire graph. N? No way. Down, up. O? Down and up. How about P? Up, up. Yep. So those are the 1, 2, 3, 4, 5 graphs that are increasing over the entire graph. So now what I would like you to do is go ahead and go through all the rest of these and put the letters of the ones that match, and then I'm going to put the answers up. So go ahead and press pause now and work through all of the sorting of the functions, and then I'll put the answers up at the in a moment here. Okay, so we did this one together. So hopefully now the rest of these you have correct. If not, I want you to write the correct answers, but don't just copy them. Talk about why you forgot one or didn't include one or included one that shouldn't be there. So minimum point should be B, D, E, O, P, and G. Constant was B, F, N. The only one that matches this description was N, and then has at least one inflection point was C, J, G, H, J, K, and L. So make sure you have these correct, and you need to understand why these certain graphs are in these groups. So now what I'd like you to do, though, is go through the rest of these problems where it says draw an example of a function that increases. There's more than one right answer here. Read this description. You want a function that decreases. So these are two drawings that you guys can do as groups. Then you want to draw an example of a function that has a minimum point. And then again, draw one that has this matches this description. Okay? And go ahead and do those. Go all the way through number 5, and then I'll put the answers up. Press pause now, and then work through that for a few moments, and then you'll get the answer. Okay, so I just drew a function that's increasing. I just kind of drew an uphill graph. It doesn't go down anywhere. It said decrease on some, then it's constant for some extended amount of x values. So I had it going like this, and then flatten out at some point, and then going up. Okay, for the next one, it says draw an example of a function that has a minimum point. So I just drew a parabola, and it has a minimum down here at the bottom. If it was said maximum, it would have been like an example would be an upside down parabola. Here I drew a function that's decreasing on some parts of the graph and increasing on some parts of the graph and has one inflection point. So it's going down, then up, and that is an inflection point. This is actually an absolute value. Okay. Next, for the sorting here, it says define what discrete and continuous in your own words are. I just wrote these two simple definitions. Discrete graphs are not connected. Continuous graphs are connected. Now, that's not what you're supposed to do here. You're supposed to do like you did before and match the graphs. So again, go back. After you look at for the graphs that are not connected, label all the letters that are not, and which ones are continuous, label all of them that are. So go ahead and do that matching using those same pages from 68 onward, and write the letters of them that are not connected and which ones are. Continuous is connected, not discrete is not connected. Okay, so hopefully you found that B, E, and O were the discrete ones, and the continuous were basically all the rest. Okay, again, it says draw an example of a function that is discrete and one that is continuous. You guys can do those on your own. And then again, I'll put the answers up in a minute. And on the following page, it wants you to do some sorting about which ones are linear, which ones are non-linear, and which ones are linear functions on the same graph. So go ahead and do all these, and then I'll put all the answers up to make sure you got them right, okay? All right, here's a discrete graph. Individual dots not connected. Here's a continuous one, just a squiggle line that goes on forever. Which ones were linear? A, E, and F were linear. Which ones are non-linear? So anything curvy. C, G, H, I, J, K, L, M. Different linear functions on the same graph. That's B, D, N, O, and P. Okay. I drew a discrete nonlinear graph, so a curve that's made up of dots. I drew a decreasing line that's continuous, so connected line. I drew a graph that's increasing, nonlinear, and discrete. So it's a curve, it's going individual dots because it's discrete, and it's increasing, it's going uphill. And the last thing you needed to do was define linear and nonlinear in your own words, and I'll just let you read what this says. And again, you're supposed to be your own words, so you can make up your own definition as long as it kind of matches this. Okay, guys, after you're done with your classwork, you're going to be taking your quiz. You are hopefully prepared by taking your practice quiz. You've done a nice job. You've checked all the solutions. And this is pretty much one of your final assessments of this semester, other than, of course, the POM if you're turning that in early. So do your very best. Take your time. Double check everything. And good luck on that.